In episode 21, titled 2.1 ETL versus ELT and Data Collection, Surveys, Sampling, and Pipelines, the focus is on how data actually gets from a messy real-world source into something reliable enough to analyze and report. The contrast between ETL and ELT is not academic, because the choice changes where quality checks happen, where errors hide, and how quickly a team can adapt when requirements shift. Collection choices matter just as much because the cleanest pipeline cannot rescue data that was gathered with unclear questions, inconsistent options, or a sampling method that quietly excludes the very group the analysis is meant to represent. The goal here is to build practical judgment, recognizing what each approach assumes, what it makes easy, and what it makes risky. By the end, the ideas connect into a single mental movie of a pipeline, from capture through transformation to trustworthy tables.
ETL, which stands for Extract, Transform, Load, is a pipeline pattern where data is transformed before it is written into its destination storage. Extract means pulling data out of one or more sources, which could be application databases, flat files, survey tools, or log streams, and it also includes basic steps like parsing formats and normalizing field names. Transform is where the pipeline reshapes the data into a defined structure, often applying business rules, cleaning steps, standard types, and consistent values before anything lands in the target system. Load then writes the already shaped result into the destination, such as a data warehouse, a reporting database, or curated tables used by dashboards. The practical implication is simple. The destination receives something that already looks like it belongs there, and the messy work happens upstream.
A clean way to understand ETL is to picture the destination as a tidy library that only accepts books in a specific format and catalog system. The transformation step is where the work happens to make every incoming item match the library rules, including consistent titles, consistent categories, and consistent identifiers. That tends to produce stable reporting tables because the shape and meaning of the data are decided before it arrives, and downstream queries can rely on that consistency. It also means the pipeline must be designed with the destination structure in mind from the beginning because the transform step depends on knowing what good looks like. When the structure changes, ETL pipelines often need coordinated updates to the transformation logic and the load targets. That trade-off is not bad, but it is a real cost in environments where data questions change frequently. ELT, which stands for Extract, Load, Transform, flips the order so that raw or lightly prepared data is loaded into the destination first and then transformed inside the destination environment. The extract step still pulls data from sources, and the load step writes it to storage quickly, often with minimal reshaping beyond basic parsing and partitioning. The transform step then uses the destination's compute features to clean, join, deduplicate, and model the data into final analytics tables. This approach treats the destination as both a storage layer and an execution layer, where transformations can be expressed as repeatable queries, jobs, or model definitions that run close to the data. In practice, ELT often enables faster iteration because the raw data is already available for multiple transformation paths, including new questions that were not anticipated on day one. The risk, if unmanaged, is that raw data can become a swamp where no one is certain which version is correct. The choice between ETL and ELT is often a choice about where strict conformity must be enforced and how much variation the downstream systems can tolerate. When downstream systems need strict conformity, ETL becomes attractive because the pipeline enforces the structure before the data ever touches reporting tables. This matters when multiple reporting consumers expect the same field meanings, the same value sets, and the same calculations, especially when those consumers are not equipped to interpret ambiguity. A classic example is operational reporting that feeds executive dashboards, regulatory metrics, or service-level measurements, where customer, transaction, or incident must have a single agreed definition. Another reason is when the destination system has limited transformation capability, or when the destination is intentionally locked down so that only curated data is allowed to enter. In those environments, transforming first is a way of defending the destination from chaos. ELT tends to shine when the destination has strong storage and compute, and when the organization benefits from flexibility in how data is shaped for different analytical needs. If a modern warehouse can store large volumes cheaply and run fast transformations, it can be efficient to load first and then let different models produce different curated tables. This is particularly useful when the same raw event stream supports multiple views, such as operational metrics, security analytics, and customer behavior analysis, each with its own definitions and grouping rules. It also supports experimentation because a new transformation can be created without rebuilding extraction processes or moving data around again. The main discipline required is governance of transformation logic, so that the truth is not scattered across conflicting queries with slightly different filters. When ELT is done well, the raw layer becomes a reliable record, and the transformed layers become well-managed products derived from it. Whether the pipeline follows ETL or ELT, it still moves through recognizable stages, from source capture to final tables that analysts trust. Data begins at sources, which can be systems of record, like transaction databases, systems of engagement, like web applications, and collection tools, like survey platforms. Next comes capture, where the pipeline obtains the data through queries, extracts, event subscriptions, file drops, or application interfaces, and that step must respect timing, completeness, and access controls. After capture, data is typically staged, meaning it is written to a landing zone that separates incoming content from curated content and preserves the ability to reprocess if something goes wrong. Transformations then shape the data into structures that match reporting needs, which could be dimensional tables, wide tables, or feature tables for modeling. Finally, publishing places the finished tables where consumers can discover them, query them, and interpret them consistently, ideally with clear naming and stable definitions. A useful mental model is to treat pipeline stages as a chain of custody that mirrors how evidence is handled in an investigation. The source produces an original record, and the pipeline captures it in a way that preserves integrity and allows later review of what was received and when it was received. The landing zone acts like an evidence locker, keeping the raw artifacts even if the first attempt to analyze them fails or a later question requires returning to the original. Transformations act like analysis steps that derive meaning, normalize inconsistencies, and connect related records into a coherent story that can be measured. Final tables become the reportable facts, which is the version that is safe for broad consumption because it has been checked and documented. This framing is helpful because it keeps attention on traceability so that a number on a dashboard can be followed back through the chain to the original source event or original survey response. Survey data collection introduces its own set of quality risks because the source system is human interpretation rather than a deterministic application event. Collecting survey data well starts with clear questions that are written to reduce ambiguity and to avoid leading language that nudges respondents toward a desired answer. Consistent options matter because free text answers are difficult to compare. So well-designed response choices support later grouping, counting, and trend analysis without excessive manual cleanup. When options are not consistent, analysts often end up collapsing values after the fact, which can introduce subjective judgment and make results hard to reproduce. The timing and context of a survey also matter because responses can be heavily influenced by recent events, communication campaigns, or even the channel used to distribute the survey. Well-run collection anticipates these issues up front so that later analysis reflects reality rather than accidental wording. A strong survey collection approach treats the survey instrument as a data schema, not merely as a set of questions. Each question maps to a variable with an intended meaning, a type, and an allowed set of values, and those design choices should match what the analysis needs later. For instance, if a question is meant to measure satisfaction on a scale, the scale should remain consistent across related questions so that comparisons are meaningful. If a response option includes other, there should be a clear plan for how other responses will be reviewed and categorized, because otherwise, other becomes a dumping ground that hides signal. Even simple details, like whether choices are ordered the same way each time, can influence how respondents answer and how reliably results can be interpreted. Survey data can be powerful, but only if the collection design respects that people are part of the pipeline. Sampling becomes critical when collecting data from everyone is too costly, too slow, or simply impossible, and the goal is to reduce cost while preserving representativeness. A sample is a subset of the population chosen to estimate properties of the whole population, which can work well when the sample reflects the same mix of characteristics present in the full group. The core risk is that a cheaper sample can become a distorted mirror, where the results mostly describe the people who were easiest to reach, most likely to respond, or most visible in the available data. In practice, sampling decisions affect not only statistical accuracy, but also the business decisions that follow, because a biased sample can push leadership to invest in the wrong improvements. The key educational point is that sampling is not a shortcut around quality, because sampling itself is a quality decision. When sampling is handled responsibly, it can be the difference between an analysis that is feasible and one that never gets completed. Avoiding biased samples requires active attention to who gets excluded and why, because exclusion is often accidental rather than intentional. In surveys, bias can appear when only certain groups see the survey invitation, or when the survey format is difficult for some respondents to access, such as requiring a device or time window that not everyone has. In operational data, bias can appear when sampling only from a convenient system that does not cover all transactions, or when selecting only recent records that miss seasonal or regional variation. The first step is to identify the population that the question truly concerns, then compare that population to the group that is actually being sampled. If there is a gap, the analysis should account for it by adjusting the sampling plan or by being explicit about limitations in what the result can claim. This discipline turns sampling from guesswork into an intentional, defensible method. Provenance is the set of facts that describe where data came from, when it was collected, and under what conditions it was produced, and it is essential for explaining results and troubleshooting surprises. Tracking provenance includes the source system name, the specific extraction method, the time window covered, and the time the data was captured, because those details determine whether a dataset reflects current state or state as of a specific time. Collection conditions also include context, such as survey distribution channel, survey version, application release version, and any known incidents that may have affected data completeness. Without provenance, analysts can unintentionally compare datasets that look similar but actually represent different definitions or different time periods. Provenance also supports accountability because it allows a team to prove which records were included and which were not, which matters when stakeholders question a metric. In a mature pipeline, provenance is not an afterthought because it is the glue that holds interpretation together. Pipelines fail in predictable ways, and a professional data practice plans for failure so the system degrades safely instead of producing silent errors. Failures can be transient, such as network interruptions or temporary service limits, or they can be logical, such as schema changes, unexpected nulls, or malformed records. Handling failures with retries means the pipeline makes a second attempt when the error is likely temporary, but it should avoid endless looping that hides a persistent defect. Alerts matter because a failure should create a visible signal to the people responsible for data quality, rather than being discovered weeks later during a reporting meeting. Checkpoints matter because they allow the pipeline to restart from a known good position, which reduces time to recovery and avoids duplicating or dropping records. The key idea is that reliability is engineered, not hoped for. Validation is the constant companion of every pipeline stage because each stage can accidentally change meaning even when it appears to produce the right shape. Counts are a basic validation because unexpected drops or spikes in record counts can signal missing data, duplication, or a changed filter condition. Ranges and distributions help identify values that are impossible, such as negative ages, future dates, or amounts far outside expected bounds, which often point to parsing errors or shifted units. Spot checks add a human sanity test by examining a small sample of records end to end, comparing what the pipeline produced to what the source actually contained. Validation is most powerful when it is repeated at each stage, because an early detection prevents downstream consumers from building reports on corrupt data. Over time, these checks create a culture where numbers are trusted because they are routinely challenged. A strong way to summarize these ideas is to keep a pipeline storyboard in mind that can be narrated clearly from start to finish, with each stage having a purpose and a set of checks. The storyboard begins with a source, where the original record is created, then moves to capture, where the pipeline gathers the record within a defined time window. It continues to staging, where the raw content is preserved with enough context to be reprocessed, and then to transformation, where business rules and standardization turn raw input into consistent analytical structures. The final step publishes tables that have stable definitions and are validated enough to support decisions, while preserving a path back to the raw records if questions arise later. This storyboard also includes the safety rails, meaning provenance information that explains what the data represents, and validation checks that prove the pipeline has not drifted. When the storyboard is clear, ETL and ELT become implementation details rather than mysteries. The conclusion of Episode 21 is about choosing one collection improvement to apply today, because small changes in collection and pipeline discipline compound into better outcomes over time. A practical improvement might be adding one missing provenance detail to every dataset, such as a clear capture time window, a survey version identifier, or a recorded source system name, so that later analysis has a stable reference point. Another improvement could be strengthening one validation checkpoint, such as adding a distribution check for a key numeric field or monitoring record counts across a critical stage that has failed in the past. The right choice depends on where the greatest uncertainty lies, because reducing uncertainty is what makes analytics credible in decision-making. When the pipeline is treated as a chain of custody and collection is treated as a design problem, ETL versus ELT becomes a reasoned decision rather than a preference. That is the level of judgment the Data Plus exam aims to reward, and it is also what real teams depend on when the numbers must be trusted. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.